Welcome to Sundar's lecture. This is lecture number 22, and what we have seen in the last class, see, we have taken a problem. This is the problem. So example number 2. So we need to find what is the voltage between these 2 points, and for that what we have done, first we have written what is the expression for VAB. So that is the expression number 1, and we have applied KCL at node A, and we have found an equation, that is expression number 2. And what we have done, we have taken this loop. So the BCDE loop, we have applied KCL, right? We have applied KCL for this loop, and we have found another expression, and we have substituted this expression number 2 in 3. So this is the substitution, and we have got what is the value of V1. So in with the help of what is V1, we have substituted this V1 in expression number 2 to get the value of I1. So now we have both I1 and V1. So what we have done, we have substituted both I1 and V1 in the expression number 1, and we have got what is the value of VAB. So we have applied KCL and KVL in the same problem, as well as we have taken the dependent sources problem. We have dependent sources as well as fixed voltage sources, independent sources. Right? We have, for today the same problem. See, we have here the values are same. This side, this VAB has been short circuited here. See, we have short circuited the VAB, and we need to find what is the value of this ISC. That is our ultimate aim, to get what is ISC is our ultimate aim, right? See, for that what we will do now, we will take this as node, this as a separate node. So you see, this is, so this is node, I am taking this as node A, node A. So what I am going to do, apply KCL at node A, KCL at node A. So you see, I1 is coming in, V1 by 6 is going away, another V1 6 is going away, and also ISC is going away, right? So you see, I1 is coming into this node, from this node V1 by 6 is going away, another V1 by 6 is going away, and also ISC is going away from this node. Both nodes are same. This is also same. This node will be same as this node because there is no element connected, right? So I will write here, I1 is only thing coming in, right? I1 is only coming in. V1 by 6 is going away. That is this V1 by 6. Another V1 by 6 is going away. So this is plus V1 by 6 is going away, and also ISC is going away. So this will be plus ISC. That is also going away from the node. So that is the thing you have to understand. So if you simplify this, what you will get, I will write here. So we will take another class. See, I1 will be equal to, this will be 2V1, this will be 2V1 by 6 plus ISC. I have taken LCM, right? Common term. This is 3, this is 1. So this is V1 by 3. So what I will do now, I need what is ISC, right? So ISC will be equal to, I am just keeping this ISC one side, I will bring this to other side. So this will be I1 minus V1 by 3. So this is expression number 1. So what I really need to find, again I need to find what is V1 and what is I1. So if I know what is V1 and I1, I can easily get what is the value of ISC. So for that, what I will do now, see, I will mark this one. So this is, I will take this loop. So for that, I will mark this B, C, D, and this point is E. So what I will do now, so I will apply KCL at B, C, D, E. B, C, D for this loop. See, I will start from this point and I will go like this and I will come to this point. This is very easy, very simple too, because we know the voltage value. See, from E to B, what is the voltage? V1. So from minus to plus, I am traveling in V1. So what I have to write, that should be V1 plus V1. And you see, I will go like this. What is the voltage source we have here? That is 9I1. I have to travel from plus to minus in the voltage source. So I have to put minus 9 into I1. That is the value. What is the voltage source value? 9I1. And that's all. We have reached this point. We have taken a loop. And that is, this is V1 and this is 9I1. There is no any other voltage sources or any other resistors are present. That should be equal to 0. So what I can write now? V1 should be equal to 9I1. V1 should be equal to 9I1. That is expression number 2. C. That is expression number 2. Right? Now what I will do? See this. I am going to write KVL for this loop. For this loop, I will travel like this. So what I can do? B, C, D, E. We have taken. So I will take this as F and this is G, like that. So now what I will do? I will apply. I will write here. Apply KCL at, see this full loop, right? So I can write like F, see this, this is F and I will write this is C, enough, right? C, B, C, D, G, this full loop. F, C, D, G, this full loop. I am going to write the KCL expression. So if I write the KCL, I will start from G and I will end at G, right? So start from G. So you have to travel in this way. So see, I am traveling from minus to plus. So I will get plus 2 and I will travel in this direction. This I1 is, this I1 current is same as the travel direction. So I have to put minus 3 into I1, minus 3 into I1. I have to travel in this way. See, there is no any elements. I can see that there is a voltage source, that is 9I1. So I am traveling from plus to minus because I have to travel in this way. So I have to come like this, right? So from plus to minus, if I travel from plus to minus, what I have to do? I have to put minus 9 into I1, minus 9 into I1 that I have written. See, that's all. No any other elements in this loop. So I have to put this should be equal to 0. Right? Very simple. Now what I can do? I can just simplify this expression. So what I will get? This is 12I1, right? So 2 minus 12I1 will be equal to 0. So I will write here. So if I go here, what I will get? So 12I1, that should be equal to 2. So therefore I1 will be equal to, if I get this 2 by 12, that should be 1 by 6 amperes. 1 by 6 amperes. So now I got, what is I1? And what is I1? So what I can do now, I can substitute in this expression, right? So substitute I1, substitute I1 in expression number 2. In expression number 2. So what I will get now? So we can easily substitute this value. V1 should be equal to 9 into 1 by 6. So what is this one? This is 3 times, sorry, this is 2 times, this is 3 times. That means 3 by 2. So V1 will be equal to what? 3 by 2 volt. We have found, right? So we have found. So you see 3 by 2 volt. Now we have both I1 and V1. So we can substitute here. If you substitute here, we will get IC. That is our ultimate aim, right? What is IC is the thing you need to find. So what I will do now? So it is simple now, right? So substitute I1 and V1 in expression number 1. In expression number 1. So you see, I will substitute ISE. ISE should be equal to, what is I1? 1 by 6 minus, what is V1? That is 3 divided by 2, 3 by 2 into 3. That is there. This 3 is already there. So 3 by 2 is there. So if you cancel these two, that will be 1 by 6 minus 1 by 6 minus 1 by 2. So if you further simplify this, what I will get, this will be 12, and if I cross multiply this, I will get 2 minus 6, right? So, so, so what I will get finally, ISE will be equal to minus 3, sorry, minus 4 divided by 12. So this can be 3 times, and this can be 1 time. So that will be what? 1 by 3 amperes. So finally ISE will be equal to minus 1 by 3 amperes. Minus 1 by 3 amperes. See, this is the final value of ISE. That is what we have found. That is what we are asked to find. That is what given in the question, right? See, if you see this problem, this will be complicated. But if you know strong basics in KCL and KVL, then this is very simple problem. See, this is actually a dependent source problem. But anyhow, we are approaching this problem very easy, in a easy way, with the KVL and the KCL applications. See, you go through this problem, this will give you further more knowledge in the electric circuit, right? So we will take some other problem. We will solve so many problems in dependent sources, since the gate questions asked in in electric circuit, in basic electric circuits, the gate questions asked in dependent sources. So we will solve many more problems in the dependent sources, so that we will get a better idea to approach the gate questions. We will solve the gate questions. You wait. I will put lectures for solving gate questions, particularly gate questions. For that, these lectures will help you. There we will solve the problems with the shortcut methods. We will do very fastly. So if you want to solve problems very fastly or very quickly, then you go through these lectures to get a better idea how to approach the electric circuit by applying KCL and KVL for our convenience, or to approach the problem in a easy way, right? So you go through these problems, and if you have any doubts, please ask me in the comment box. I will reply in the comment sections, right? Thank you.